Here's my circuit. This is where we did our impedance calculations. Right here is where we have our thermocouple right here. And we have 3.3 input, ground, DO, CS, clock pin. Going to our IOC, we can see that our black pin, which is our DO, will be connected to PC2. CS has to be connected to PB15, clock to PB10, and then that coincides with our microcontroller wiring. Now to gather data, we will press the blue button, and then to stop, press it again. So right here, stop at 0. And then if we put our brass ball into water, you'll see that the temperature will decrease and change. Currently, I already had the water I had the ball at a higher temperature, and it's pretty much at the same temperature as the water. So then what we did after getting our data points is that I first did hot, which is pretty close to boiling. Then I did cold, which was really close to freezing, which will impact the values I got for the heat transfer coefficient. And then so hot water graph is here. This is our raw temperature for the cold water, and then fine tuning by getting our adjusted time and temperature. This is the graph we got. And then this is our equation. And then we will use this 0.149 to the power times x exponent. We will compare that to the lump thermal capacitance. And by doing so, looking at the lab handout, what we'll do is that we'll have set theta on the top here. We'll set that T of t approaching to infinity. So once we get the ball temperature to be at the same temperature as the water surrounding it, then we can use our graph to compare to when T of t is equal to T infinity. And by doing so, that will be equal to 0. So this whole side will equal to 0. And then we have exponent of the time constant. And then we can equate the exponent of the time constant times t equal to our exponent value we got here. So we do not need to use this coefficient in front of our exponent. Then by doing so, we can find the time constant with the time constant, and then we can find h if we equate the exponent to this here. And then afterwards, we also need to verify that our system satisfies the lump thermal capacitance criteria, which is that it has to be less than 0.1. This is just an error in the sheet.